and I'm trying to write it as close to the way that they would write it on the test format, so that when you see it again, it'll be, oh, okay, I know what I'm looking for. All right. So it says here, y equals negative 4 times log of x, log base 10 of x. Solve for x when y equals 4. This is how it would be written.
Log base 10.
Right. My hint to you will be, step 1, you'll need to plug in some information they've given you. Step 2 is where you do base and switch. So step 1 has to do with plugging in some information they gave you. Step 2 is base and switch. So it's going to be an ugly problem. We got to do something with that 4 and. Hey, wait a second. Y equals. Okay. All right. And that's the idea. Correction, this y should be an 8, and not the 4 that I had there. Oops. Just a little hint for those who are, think maybe I may not be able to solve it, but I want to be able to at least start it. I already told you about the y substituting in first, but the second hint would be, before I can change it from the log form into exponential form, with the base switch thing, I also have to get rid of this negative 4 that's being multiplied times everything. So step 1, plug in what they gave you for the y. Step 2, get rid of a negative 4 being multiplied times something. I do that by doing the opposite of multiplying. Can't say, but, and at that point, once you have the log and the x by itself, then you can do that base switch deal. And I wish some of our base switches on that paper, none of them seem to have a base 10. So some people are like, I don't even know what the base is on this one to be able to switch. So it's going to be a lot. The good news is, this other one is to make you feel like, we're going to put this on the test. Once we do a second one, then you're like, oh, okay, I see all the pieces. All right, I'm good. So again, let me hold it for a moment. All right, so here we go. You guys kind of walking through it, and then we'll give you a second one. If you didn't get to finish it, that's fine. My goal was just to get it started. Say it again?
Can I go up and write it?
This time I'll just do it with your help, though. So tell me what you did first.
So no.
All right, so what's the first thing you did, Anna, or someone else?
Like me.
Excuse me, is your name Anna?
Or somebody else.
Or someone else is taking a little bit, but I appreciate you all in high school being.
Okay, so then you divide by negative 4?
All right, so this was the extra part here, this negative 4 part, which I did see people do, and if you didn't, you can write it right down with me. So we got that negative 2. Now here's the part that I didn't look to see, but this is the part I expect that would trick somebody. I have the log version. I need to write this in exponential form. Here comes the question. Can anyone tell me what the base is?
10.
Yeah. When there's no base, it's a 10.
What is this?
And that's the big deal. Once you have the base and switch, it's no big deal. And now I see that 0.01. It's kind of coming to view. So here it comes. Here we go. Base and switch. Negative 2. And equals that x. So x. Alright, take a look at that part, write that part down. And at this point, if you were able to get there, then your calculator goes into effect. Someone tell me what that equals.
X equals 0.01.
0.01. If you did not punch that in the calculator, please do me a favor. Punch that in right now to make sure that you would be able to get it. All right, here it goes. Go ahead, write down the instructions so that you're used to them. And again, please put standard 3 on these problems. That way, when it's time for you to study, and you're going to need to study for this test, you won't just be able to walk in. you'll know. I think you guys have it. Here we go. Step 1. What am I putting in place of the y?
On Snapchat.
30.
30. Thank you very much.
Can you like have respect?
And then you divide by 60
Divide by 60.
No, Anna.
on both sides, and then equals 0.5.
We got our log x. By the way, what is the base?
10.
10.
And base and switch and solve.
Base, switch.
And then solve for x, and x equals 3.162.
Did it switch to the 3-point? Okay, good. The important part here, of course, once the x is on one side of the equal sign, then you know you're just punching it in. So again, on the on standard 3, they'll have some of these where you just have to punch in the numbers once you do all of this. They'll also have one of those where the x will be up high, and you'll have to do the circle and draw down where it's log divided by log. It'll be one of those. So when it's time to review, know we'll have 2 versions in the same standard. Let's now go on to standard 1. There's a problem. I'm going to hand out this this handout. I didn't want to go to it first, but I think I'm still going to do it right now that you're in the sky here. Standard 1. For the next page, 70. Page 70.
Do you put it on? Yeah, this one here. Just real quick.
I'm having technical
No, he likes it.
difficulties.
What?
He doesn't.
I can't do that, but
Can we just do it? Please?
Do me a favor, put standard 2 on page 72.
do it.
Standard 2 on page 72.
No, it's just
Write it down, write it down, write it down. Flip the page.
like that.
72 on 72. Flip the page to 69. And we're going to put standard 2 on 69 as well.
72.
Standard 2. Because standard 2 is actually one of the most jumping sections, standard 2. And oddly enough, this 70, it's a review last unit. You know how you move things up, down. As a matter of fact, I'm going to say this one first, just get out of the way so we don't have to think about this anymore. And then we'll jump back to standard 1, last unit.
What are we doing on Thursday?
Thursday, we continue with some more of these graphing and final preparation, probably for the test, either to begin it on Tuesday.
So if I wasn't here on Thursday, I would miss a lot.
I'd say a lot, but again, the video will be there, so you'll be able to look up whatever was missed. All right, so here we go.
I'm gonna go to a protest.
Oh, that's cool.
It might be the same one.
Students for Justice for Palestine.
Alright, never mind.
Where are you
What
going?
protest are you going to?
I'm not going to. I'm just
All right, do me a favor, do me a favor. On this one, they're asking us to take this original. If you have a highlighter, please put a highlight dot right here, so you know where it starts. And then from there, notice the new dot over here, where it ends. What they're asking you is, hey, how do I rewrite this equation if I move things down? How many times did I move it down, by the way?
1, so I'm just gonna make one.
It ends at -1, but depending on where it started, how many times did it go down to get down?
Twice.
2. Yeah. It moves down to
I can't count.
right
That's
down,
what we're doing, okay?
right down over here, the equation, but with a new way to show that you move things down 2. So here's where it started originally. Then, as it was said, 1, 2, it got bumped down twice. How would you rewrite this thing to show that it was bumped down twice? This is from the old unit or whatever.
Right, that's what you on.
Right of f of x. Oh, I see what you said, right, the new one.
Yeah.
That's a good point.
we don't have to, right?
No, I'm going to write it in though since you brought it. But instead of a f of t, it'd actually be a g of x, saying, oh, this is a brand new equation. Because the x bar is still there. The 3x is still there. The extra part is what you can add, and that's when we come around and just see what you may have guessed there for a moment. What are you putting on this one? I saw it. Somebody finish it off.
2.
The -2, and again,
I was gonna say 3.
the original where the 3 is raised to the x power, that part stays the same. They threw it in here, I'm not exactly sure why, but I figured since it's attached, then it could be that. Look at it.
What do you change to move it on the x-axis?
You would put a parenthesis around the x, and let's say if you want to go left, right, it'd be, say it moved 2 to the left,
Yep.
then it'd be x plus 2 because it went in the negative direction, but it would be inside of the parenthesis. So up, down is always at the end, you're the very last thing. Left, right is in there. All right, let's get deeper on this thing now. The cow, no, not on the cow. All right, I'm going to make you read it, and I'm going to make you guess how to set it up. Once you set this one up, like before you start getting the answer. Oh, this one, oh yeah.
It's hard. I don't want to do this.
He's going to, well, let's just start. Read through here. Basically, you need to figure out, you need a number on the other side. Your job is to read through the problem and guess, based on the information I give you, what number goes on the other side. Once you get what number replaces the I, then it's going to be your task to somehow try to solve this one. By the way, this problem reads this way. I equals 10 to this fraction, this dv, even though it's 2 letters, it's as if it were an x over 10. In other words, the x is in the exponent, and when the x is in the exponent, there's a certain way we solve it. My hint to you will be, and again, yes, we started with the nice and easy ones. This one is one of the top sections. The reason I started with the top section is so that you get used to doing it. Okay, no tricks to begin with, so that when we get here to the test level problems, when they try to do a trick, at least I can refer you to the kind that, oh, okay, I remember these. When the x is above, I circle, I draw an arrow, the 2 logs, and so on. There'll be one extra step to get rid of this extra 10, but do this one. Step 1. Recording? Yes. Step 1, attempt to figure out what goes in the place of the I. Step 2, see if you can get the exponent down from in its position. Because we've got to get to that dv somehow. And we can't get to it if it's floating up in the sky. We have to tie something to it to bring it down from the sky. So do this. Try the steps 1 and 2. Step 1, what am I placing in the place of I? Step 2, how can I get this dv over 10 down from the exponent? That's the goal right now. All right, try that one, and then from there we'll go on to the next part, which is the graphing. Let's pause. What number are we putting in the place of the I? Yeah. Now, here's the beauty of these problems. Even if you're not quite sure about it, it looks like the test questions, they're only going to let one number be out there waiting for you. And so you put that in. So I saw that. You put in the
I thought you guys were...
the 1,000
Go ahead. We were gossiping.
equals the 10 raised to the... I wish they didn't have 2 letters for the dv, which makes it seem like it's more than one thing, but it's as if it were just an x. As a matter of fact, I'm going to rewrite it next door to it, so it can look like what we're used to, where we just have an x. So if I were rewriting this problem, it might look like this. The 1,000 equals the 10 raised to the, let me just make an x over a 10, so that it can look, instead of like having 2 things, just that x. And if you were to rewrite it this way, just so you can, I almost want you to put that on your paper so you can have both versions. I'm going to start to solve the version that has the x in it, and then switch it back to this weird looking thing. Hey, what's the idea behind that? Make it look as much like something they've already done before, so that the brain's like, okay, I remember that, remember that, remember that. So that when we switch it to this dv, like dv, like, am I solving for d or am I solving for b? Is dv one thing, decibel? It is just one thing, but since I'm not used to it, give me the other part. Is this in standard 1? Yes. Can they make it through standard 1 without this one? Probably no. There are only 3 problems in standard 1. One looks like this. I think one looks like there's another problem we did on there with, I think, bigger numbers. But for sure, this one, once you put in your 1,000, everyone should be able to have this one. Here comes. I saw what somebody did first. To get that down, I'm going to do the long version. To get anything down from here, you have to, let me rewrite it. You have to write a log to get that balloon down from the sky. What balloon? The balloon that has the x and a 10. To get that down,
Yeah, which one?
you have to write in log on this side and log on this side. How do you get a balloon down? You tie it to a log, it comes down. And here's what it looks like. When it comes down, you wind up with the x10. You got the x over 10, x divided by 10, log 10. That is ugly, and it won't even write for me. Okay, never mind. Alright. Alright. So write this down. And you already, I think you already have also, write this part down. The log 1000 is over here.
I want to do that one. I want to do.
Yeah. Fight through anyway, fight through anyway. I think you can.
From like 8 to like.
So write that part down, write that part down.
Maybe to like 11.
The last step, oh, look at this thing.
Look at it.
We're not even at the last step, but we got to step 1 to get the x and the 10 by itself. We're going to divide this log 10 on both
No, you
sides.
don't have to do that. Because log 10 is just 1. And then I multiply by 10 on each side. Okay, hang on. Can I just solve it on the board?
Well, let's do this version, and then let's hear the other version that you're saying, because I don't think they know that, oh, log 10 is 1 yet.
Oh, okay. Okay, Pez doesn't know log 10.
Write that down, write that down.
Because yours not there. Probably.
This is ugly. What do you see, what do you see?
What's wrong with you, Eric? Wait in trouble.
So what is it that we did, so you know what you written down? To get the x10 down, you write log in front, because the rule says as long as you write a log in front, you can bring down the exponent in front of it. And so you can see right here, from here to here, you have it written right there. To get the x and the 10 alone, because they're being multiplied times the log 10, we just divide the log 10 on both sides. That's what you have here. In your calculator, you would be left with this. On this side, do me a favor, punch in to see what Sam is saying. In your calculator, please punch in log 1000 divided by log 10. Just make sure that you put parentheses at the end of those, and let's see what number that spits out.
Sounds like a robot. The log 1000.
Mm-hmm.
That wasn't a joke.
Observation.
3.
Oh, we have to get it.
I heard a 3 here. Anybody else get a 3 before I write it down?
Yeah.
Yeah, I got 3.
Okay.
Don't worry about it.
Yeah, you just got to trust your calculator on that one, that if you do the log 1000, which actually turns out to be 3 on its own, divided by log 10, which actually happens to be 1 on its own, then it is true, 3 divided by 1 is going to be that. Because here's technically what's happening.
You're just counting the zeros.
Right, it is just doing that. If you have log base 10 and log base 10, yeah, it's saying, what do I need to raise 10 to get a 1000? Oh, to 3. What do I need to raise 10 to get a 10, a 1? And so my thought is, it's the moves, the calculator will figure out this stuff. As long as you put it in the right place, then you'll be okay with it. The last step, how do I get this 10 down on the bottom? Because it's divided by 10, and when I do the other one, I may do the short version.
Yeah.
Last step, oh, this is so long. What are the chances that they're going to miss one of the moves in there? All right, here it comes. Nonetheless, let's see if I can write that.
I'm encouraged.
Also, with the interpreter, and like the good slice to them that they're Mormon. And it's
She
so nice to
like
get those. Oh, are you guys from Utah?
Times 10.
Oh my
Keep
god.
writing. You're at the end now.
And they just looked at me, and I'm like, oh, I don't think that's offensively like asking me.
All right, and then the last part here.
I was like, I know what goes down there. Are they really from Utah? One of them was from Utah, one was from Texas. Oh,
30.
I think it's better. Okay, that's fine.
I'm from Texas.
That's not as bad as hi, Amanda. Oh yeah.
I'm from Texas.
Oh man, that thing is killer, and they need this one. Oh shoot.
Like we have another part of Utah.
So,
And then
a problem that looks something like this. So this is very important to kind of know. They are going to ask you to find the x-intercept or the y-intercept, which is going to be hard once we get a calculator. And then they're going to ask you, hey, tell me about the line. Is it going up high or is it going down low? What's the line doing? The way they'll say this, hey, what's the end behavior? So step one. The initial amount, the A, this little formula, of course, from last time, because I'm going to have you fill in the one right next door to it. So I'll remind you of this one, fill in the one next door, and then let's see if we can tell you two things that you always know, and then we'll put in the calculator. All right, here it comes. Yeah, not with those, not with those. So here it comes. In this problem, the initial amount, usually some money amount, and they're going to say something like the percent of the money is going to keep increasing or something like that. So in this case, we did it before, the 360 is the initial amount. If you had to guess the original money amount. You see these 205s all over the place? Usually not a year is the initial amount. It's going to be some kind of a money. The next thing is, what is the growth factor? In these, usually there's going to be a percent. It grows by 7%. It decreases by 5%. Yeah, hold on. So I can get through it. So in this case, once you get the percent, the rule is going to be this. If it asks it to grow, you have to do the percent 1 plus whatever that percent is. And that percent has to be turned into a decimal. This is a reminder from what we did last time. And we're doing what's called space review. So 1, 2. So we have 0.07 plus 1. That is, we have $1 plus 7 cents. So the growth factor, the B, is going to be 1.07. Okay. Once we have this and we put it in the formula, it's the formula I want to mention when they ask you to find the y-intercept. Finding the y-intercept is always easy if you know what to look for. So let's write the formula, and then I'll tell you how to find the y-intercept, which will get you a point. And it's easy if you know what you're looking for. So the A is a 360. The B, sometimes we'll just write in the parenthesis, it'll be that 1.07 raised to what power? It's going to be the same little x that you have there. Step one, no big deal. The only so many numbers they give you. The percent is generally the guy that's going to be in here with the number 1. The outside guy is going to be the money. And it doesn't always happen this way, but because this type of problem is so famous, at least you get that for free. Here comes the question. At some point, they're going to ask you for the y-intercept. I'm going to give you this guy for free, and then I'll have you set up the next one, and we'll put a few in the computer, and then that'll be that. So the y-intercept, of course, is, hey, what is the number y when x is 0? That's what a y-intercept is. Okay? The answer is this. If I were to put a 0, this is the long version of it, but this red number is going to be the answer. But let me say why the red number is going to be the answer. If I were to put a 0 in the place of x, anybody know what 1.07 raised to the 0 power equals? 1. It equals 1. And the minute it equals 1, it'll be 1 times the 360, so that y equals the 360. In other words, when you put 0 in the place of the exponent, whatever is there essentially makes it disappear because it turns it into 1. For that reason, no matter what is here in the green section, when they say, what is the y-intercept, what they're really saying to you is, hey, do me a favor, put 0 in the place of x. Make this whole thing turn into 1 so it disappears, so that whatever is in the front door wins. If there were nothing here, this number would be a 1 in the front door. The red number would be a 1, and therefore the y-intercept would be a 1. So, here's what I want you to do. The problem next door to it, number 16, the problem will be quite similar. The only difference is they're going to have an 11%. I'm going to have you do it exactly like this one, even though they use the word decreases, which makes you have to do 1 minus that number, but I'm not going to do that. I'm going to just make you do it exactly the same way. So go to 16. read the problem. The only thing I'm going to have you change is instead of the word decreases, I'm going to make it say increases so that this thing will look like we just did. Then we'll go back, we'll draw two pictures. We'll do the calculator, computing on to your hand, Anna, so that it will, you'll be able to factor on this one. The K factor, the number in the parentheses, we do 1 minus the percent, but just to keep it exactly the same. I don't want to do too many switches at once. So we're going to make it grow. You're going to choose your A and your B. Read through the problem, see how many different numbers they have floating around in there. See if you can choose which one you think is A. The B, fortunately, they have several numbers in there to choose from. I need to read through this one. For setting it up, shouldn't we back up? I'm probably going to say leave out the other part. No.
Oh, I just left at the 3,000.
Right, that's what I'm thinking as well, because that's the final question that you already need a formula to. But let me back up to how to answer this one. Spend 1,000 increasing altitude. The pressure decreases. 3,000.
Same thing.
This one is a little trickier, but we're going to leave out the
You always sound sarcastic.
3,000. What is the main thing I want you to get to on this one? The main thing I want you to get to is at some point I want you to choose what the y-intercept is, but that depends on what you choose here. And I am going to make the initial amount the 1,000. Recording this part.
I thought it was 101.
Why are you cheating?
Do you think the 101? Let's take a look and see why it might be the 101. Let's take a look at that and let's see if I chose the wrong number. Because again, when they have several numbers, let's see, the atmospheric pressure at sea level is 101 kilopascals. For every 1,000 increase in altitude, the pressure increases by 11.5%. What is the approximate pressure at an altitude of 3,000?
So since we're adding on to the pressure and not the height, then it should be 101.
Yeah. She is right, that 1,000 should be there because this is the initial amount and they're trying to figure out if we change the pressure, how will it switch from the initial amount?
So we're changing it back to 101.
I'm going to put it to 101. But the main goal on this one, even though I didn't realize they were going to switch it to this problem, but I thought they were going to do another money problem and look at it as closely, is once we have the numbers in place, and on the test, the main goal will not be necessarily get in place. It's going to be once we have the formula, which I think they're just going to offer you, what will the y-intercept be, and what will the picture look like? The picture will always look like an airplane taking off, which is what I'm going to show you in a second. And then we'll punch into the computer a few times. Go ahead, Eric.
Would the would X be 1.115 or X B?
So the B is going to be that 1 point because I'm always going to add for increases. If this were a decreases, you do subtraction. And again,
Oh.
so let's see if we can write out the whole thing. My hope was not to make all this part hard because you lose gas, but my hope is, okay, what if I had this and it looked weird like this? It looks like a parenthesis 1.115
That's what I put.
raised to the x. The question that I really want you to be able to answer is, hey, can anyone say what the y-intercept will be? The y-intercept is always your letter A. That is, when you put 0 in the place of x, it always makes this part disappear because it'll turn it into 1, and then whatever that A was becomes the y-intercept. All right, so the y-intercept is going to be the
101.
101. And then and make sure that
You're rude. That's mean.
They're really having like you or thing.
I'm not.
all right, let's see if we can do this thing real fast. Now go ahead, get the computer's going to plug a few of these into.
One time someone like invited me.
So grab a computer, and then I'm going to sketch what this graph is going to look like. For exponential functions, which is the picture we're drawing, I'm going to put a little picture down here so that you will always know. An exponential function where it is growing will always look something like this. An airplane starting here, and then it will take off into the sky like that. The only main pieces that you kind of need to know if you were just sketching is, where is this airplane going to hit the y line? Where's it going to crisscross on the y line? That name is called the y-intercept. So let me ask this question. On this picture here,
I'm just gonna look on the pad.
okay, it is. On this picture here, where is the airplane going to hit the y line? Or in other words, what is the y-intercept? So let's say I was sketching a picture, and we'll see if our computer does it for us. If I were sketching a picture, for this one here, somehow I'm going to put in 360 somewhere. For the purposes of this sketch, do me a favor, put in 360 right here. Now I know that on this picture that's 1, 2, 3, 4. Don't worry about the computer right now. Right now just sketch it on your paper. On your paper, just sketch this one. I know on your paper, 360 probably really wouldn't be there, but just for the idea, on your paper, put 360 here, and then I want you to draw this sketch. I want you to draw the sketch where there's an airplane starting here. It's starting out, and flies into the sky.
But it never touches zero because that's the asymptote.
That is the asymptote, which is one of the questions they're going to ask you. But for now, if ever you have to draw an, please draw the what's it called, the graph of an exponential function. This is something that you're going to get most of the time. Unless there's a negative sign in front of that which makes it go down, this is what you're going to get. Do me a favor. Actually, go ahead and punch that problem into the computer. And then I got my fingers crossed that it's going to fly.
What is it?
I'll come around on page 12 and check you off in just a moment. See if I can get to that.
Hey, Jacob.
Yes.
What did you do on Thanksgiving?
Nothing important.
You want to go play football?
Wow. Where?
I think we're playing this year. I think we're playing at full high.
10.
I'm not really into sports, but I guess I'm down.
There were 2.
All right, I'll hit you
If
up.
I don't decide to stay on
Well, we start at 7 in the morning and then you go until like 9.
Alright,
It's like a real game, basically.
so let me come and check you guys off on this. All right, I saw it on your papers. Good work.
Future.
it's natural.
Future.
0, comma 10.
Thanksgiving morning?
I used to.
All right, here comes the last piece of the puzzle for this type, and then we may, we'll punch in some more next time. Last piece of the puzzle, they're going to ask you the following question.
What?
Do you celebrate Thanksgiving?
What is the end behavior?
I do.
Let's see, can I write it here?
What do you do?
I have friends.
I'll just have them write it. And
I have friends.
I have friends, okay?
Eric.
It's hard to believe, but I have friends in the Thanksgiving spirit.
write this down. This is the last one I'm just going to introduce now so that when I say it next time, it won't be the very first time you've heard it.
Probably not in behavior.
Yeah.
And behavior.
Me too.
Oh, you guys, okay, good.
It's interesting.
All right.
We're not peasants.
So write those down, and behavior. I'm going to start it with arrows. I'm going to start with arrows, and then we'll put in the words that go with it.
It's not roll today.
Here's what the arrows are going to say.
I don't get it wrong.
As we travel this way, what is the red line doing?
It's going up.
Yeah, red line going up. So very simple. Here comes the opposite, though.
It's going
When we go the opposite direction, what is the red line doing?
down. Stop. Decreasing.
It's going down, but it has a limit. It won't go below this
It's
line here.
approaching
Yeah, it's
the
approaching the line.
x-axis.
Okay,
The
right.
S.
Sure.
So it won't go below 0.
I don't know.
Okay. So it won't go below 0. The question is, how do we say this and how do they want it said? The right side is nice and easy. You did it on Unit 1. The left side is a little different, so let's write it down. this right side, as x goes to the right, and you might know what number is to the right?
Infinity?
Yeah, they're going to use infinity. Just say the direction. Hey, as x
Can we say
goes this way.
Increase infinity.
Okay. So you're writing what I'm writing. As the x goes that way, the y is also going up forever and ever. And so the y goes to positive infinity. This part usually is the easier part. Here comes the tricky part that's going to mess some people up. But I'll let follow through. Treat it like the first part. The second part, how do we say you're going to the left? Oh, where you go towards negative infinity. I'll write this part in green so it looks different. As x goes to negative infinity. The question is, well, what is the y doing? The y is trying to go down. It can't go past that line. As a matter of fact, it can't even touch that line because, as Jose said earlier, it's an asymptote, a line that you approach but that you never touch. This line actually has an equation. That equation is y equals 0. This line here, if I had to write an equation for it, the equation for that, the x-axis, is actually y equals 0. So the way that we'll say it is this: the x approaches 0. All right, look at it.
Does the line ever reach a stable number
No.
going down?
That is, there's this red line as it approaches 0 to that reach. It does not. By definition, an asymptote says it has to go on forever and
Number
ever.
just keeps getting bigger.
Right. So the way they would say it is, it keeps trying to approach 0.
Oh, yeah.
All right. Do me a favor, last move.
Oh.
Final move, then you're good to go. Go to page 16. Page 16. This is it. You did it. You're going to write down the y-intercept, and then you're going to put down the end behavior.
Was that yours?
The good news is with these, the end behavior does exactly the same thing. So go to page 16.
Okay.
Or was it 15 that we did? One of them we started off, but we didn't put the...
16 is the one with the 101.
All right, 16 is the one we did. We wrote down what the y-intercept was, but we did not write down what the end behavior is. On 15, please write down what happens as we go to the right. In other words, we go towards positive infinity. So again, this is good. And then write down what happens as you go to negative infinity.
I think I'm still coming.
Okay. And it may even go on after 12. All right.
No, I don't want to go at all, actually.
Okay.
Then where are you? I don't like.